Okay, Mike Bryles, medsim300B, Medicine, Dallas, Texas. And we're just going through the basics of the Fluke Biomedical medsim300. With it, this is one of our workhorse simulators that we've had for a while. With it, medsim300B has a full 12-lead, 10-electrode system ECG. This is independent output ECG, allows you to simulate physiologically very accurately the true body's conduction. Uses a analog multiplexer circuitry so that there are actually 9 independent signals referenced to RL. So very, very accurate for doing arrhythmia simulation. Would be an interesting try to run this on diagnostic recorder and look at left bundle branch block, and look at the time differentials between the leads, and then look at the diagnostic results. Works very well. Okay, so with ECG, full capability for modifying the baseline ECG in terms of rate from 30 to 300, amplitude from 0.05 millivolts up to 5.5 millivolts. ST segment, it's a linear elevation or depression of the ST segment. That's something we use for looking at different stages of the MI. And at a setting of 1 millivolt for the R wave amplitude, now we will do 0.1 millivolt elevations and depressions from 0.1 all the way up to 0.8, positive and the negative direction. And also we will do a 0.05, which is one of the threshold levels for the ST segment set by GE Medical for their silent ischemia systems. So even something as fine as 5 microvolts, that they are wanting to, 50 microvolts, that they want to be able to measure, we can simulate with this. Axis, then basically looking at normal is an intermediate axis deviation, and there's then 2 electromechanical adjustments you can have with the heart also. It's a horizontal axis deviation or a vertical axis deviation. And with it too, you can then simulate a neonatal ECG. So it'll take what we have in the adult ECG here, decrease the PR interval, and also make the R wave narrower. Mm-hmm. So it is more so what the baby ones are running. So as you can see here, we are bringing it tighter, shorter interval, and a narrower R wave. So definitely if you have any of the neonatal monitors, that does work out quite well. That also lowers the blood pressure by 25%, so the pressure is a more comparable what you'd be looking at for the babies. Performance tests. This is complete capability here for both doing just basic waveforms. You're looking at just setting a baseline for your ECG. That was just a matter of luck. So basically, we've got an ECG. We also have a DC pulse, where it just simply outputs a 1 millivolt amplitude. Square wave for doing a basic low frequency test. And then also this different square wave for doing a gain test. And also if you want to also check your recorder, gives you the ability, for checking that too. Mm-hmm. I think we're just eating our paper here. Okay, it's throwing you. Okay, so we can do that. And then we also have a triangle wave. Okay. Now for triangle waves basically are for looking at the span or the range of amplitude. You're looking for the quality of the trace, and if you're losing any bits in your A to D converter. This looks okay. Refresh, a little nasty, but that's a different story.
Yeah.
And then sine waves, we're doing different frequency response breakpoints. We have very low frequency sine waves. We're doing your low end frequency response, and then we then also have some higher ones here too. Typically, you're looking at a 10 hertz sine wave, but also too that you can also find out how this is set up for doing line frequency rejection. So we have a sine wave for 50 hertz. So that looks pretty nasty. So undoubtedly this is set up for a 60 hertz system. And we turn on 60 hertz. That's pretty nasty too. So we'd probably just go back into a function select. Okay, there we go.
Expand.
Yeah, we're okay there.
No?
Okay. There we go. That cuts it back a whole bunch. Yeah, in the diagnostic mode, you've got a very high frequency response. It's a 3 dB down point at 100 hertz. So in the monitor quality, it does cut it back a little bit, but yeah, I'm a little surprised that it's not just a little better than that. And for the diagnostic quality systems, typically it's a 3 dB down point at 100 hertz. In this mode, it's pretty well shot out, so that would be a typical response. At the monitor quality, 3 dB down is something that's typically under line frequency, about 35 to 40 hertz. So it doesn't even know it's even there. So that's a typical response. But again, at the bandpass, most of the information in the ECG is from about 1 hertz up to about 40 hertz. And then sometimes they will look at higher frequencies, but that's the majority of your waveform content. Okay. This test is something where that it's set up where that if they say they're having a problem with the heart rate meter, being able to pick up a certain ECG, this is something that you can run and verify the operation of this. One of the reasons we had developed this, we talked to many hospitals about, I'm having a problem with my rate meter. It's not picking up the patient's ECG. I said, well, what's the ECG look like? I said, well, it's an older person with a wider R wave complex. So I say, it's a wide one? Okay, so you say it's about 160 milliseconds? I said, yeah. And then I said, well, what's the amplitude? Well, I don't know. So let's just say it's 1.5 millivolts, something like that. He said, yeah. I said, okay, well, there it is. How's your system working? So we were able to better test the system, and there are requirements for that in the different ANSI AMI standards, and we're able to cover that full range with the medsim300. For example, that with the neon codons, they usually have a rather wide, complex capability. So even if we bring it way down, 8 milliseconds. Let's see what it does here. Okay, it doesn't pick that up. But what we can do is hit the auto again. We've got that capability in there. And just wait for it to begin to detect it. It's 12 milliseconds, 20. Okay, now it's just begun picking it up. Okay, at 20 milliseconds, it's working. So that's a relatively, it's a good number. But again, too, it's nice where that in those very narrow selections, which are typically below what you would normally see for a cardiac cycle, you're able then to very readily simulate it and see how well it can reject it. Because like when you are having a very narrow R wave complex, your rise times are very sharp. Mm-hmm. It's going up very fast. Mm-hmm. And there's a certain window for that slope that the R wave detectors will work. And you're able then to test all that by using this mode. So again, if you say you're having problems with the rate meters and you want to be able to replicate the waveforms, you can come pretty close, with the medsim. Both in amplitude, 0.05 millivolts all the way up to 5 millivolts, and then from 8 milliseconds up to, I think it's like 220. Yeah, 200, I should say. So it works out quite well. Good little system for making those measurements. And again, under ECG, you've got the arrhythmia capability. Mm-hmm. And with it, we don't have as many pre-programmed arrhythmias as what's in the MPS 450. But what we do have is a user programmable mode where you can go in and program custom activity for your PVCs. Mm-hmm. So as with the MPS 450, very similar. Supraventricular, top part of the hearts, premature beats, then ventricular series of arrhythmias, and then conduction defects. And with it too, then we also have paced arrhythmias, and again, like the R-wave detector tests, we've got that pretty much covered, where we can go in and do a full AV sequential pacemaker. And what we can do is go in and change the amplitude of those pacer spikes. As you can see on the monitor, it says it is pacing, and it is picking up the pacer spikes. It's a AV sequential, so it's going it's pacing for the atria and also pacing for the ventricle. And with it, let's say if a nurse or doctor is complaining and said, well, my monitor isn't picking up the pulses. I said, well, let's just give it a try. Let's go into amplitude. You can go in and bring those amplitudes all the way down. Mm-hmm. And that's right there to nothing. And you can see it's fully erased. Mm-hmm. Now if you want to do it again, you can start. In this case, it's a negative going, so it's beginning to grow. And as soon as it gets a little bit larger, you're going to start getting a little bit of a double beat. So basically all I'm saying is just give you the ability, to run the different parameters. Probably easier to run this with a single channel pacer, so we don't have both pacers going off at the same time. Okay, so there's your waveform. Okay, it's relearning that. It doesn't know what it really is. Okay, so now we're beginning the pulse. And as soon as it recognizes it, we can hit the stop. Okay, there you go. So with a pacer spike of 12 millivolts, it did pick it up as a pacing. And this is a unique feature of MPS 450 and medsim. You can actually look at that pacing window on the system. And this does cover the full range as specified by the standard, and that's plus or minus up to 700 millivolts. So it's a very large amplitude spike. And that is something that is typical, when you are pacing, with the internal it's a transvenous type pacemaker. And this is just a very straightforward little mode. First off, let's go to ECG, base, ECG 80. Okay, this is called the insert mode.
Nice.
So let's let it let's let it come back to the world here.
Yeah.
I wonder if it was the monitor or me. It looks like it's the monitor. This one looking for the baseline to resettle. Yeah, I think the monitor has a little problem here. We have been beating it up pretty good.
Shows fine.
Okay, so I'm putting this to zero baseline on it now. Again, in this one diagnostic mode, this is the same as shorting all of your leads together. Okay, they're happy now. Okay.
80. Yeah.
Okay, so we're in good shape. Yeah, in that one mode though, it's called an insert mode. And we can insert a single shot PVC, premature ventricular beat, just by a push of a button.
Just one?
Yeah. And also a premature atrial contraction, so it's just a normal one that's a little bit. And then a nodal rhythm, which gives you a reversed P wave, but again a premature beat from a little lower in the heart at the AV level. Okay, and we didn't cover this. This is a custom programmable PVC mode. Whereas before you could just insert one if you'd like to at any time. What you can do, you can select one of any 4 focus points of PVC, left ventricle and right ventricle, more of a standard morphology. Then F3 is a left and F4 is a right at different sites within the ventricles. So you can pick, okay, that's a focus of number 1. You can look at the interval of the coupling from the previous normal beat. How many happen per minute? So you can bring that up to 24. And at the end of it, there's your little elapsed counter. So you can say how long the test is run and how many PVCs have occurred. So especially if you're looking at a system, an arrhythmia counting system, that's what these have, you can use this for checking them out. So let's say, okay, this has the ability for measuring arrhythmia activity, ventricular arrhythmia activity. Okay, so let's run something that's X number of PVCs per minute. And so we'll say we'll clear this, set up the monitor, start that, and then start that one. And now you're running PVCs. We're counting them because we know what we're doing.
Sure.
And then you can stop this and hit hold, look at the elapsed time and how many PVCs occurred, and you'll see how many that this system caught. So just a very simple way without having to use the computer or anything for programming. Do it all here manually, with the analyzer. So in this case, it's really more of an analyzer than a simulator, but it is really doing both. And we do have fetal ECG capability, like you have the old Space Labs AMS.
Yeah.
You can use this for testing the fetal ECG, scalp electrode type, and also the intrauterine pressure simulation. That's all within this menu. So you can go in and adjust the fetal ECG, different fixed rates, or you can also do dynamic simulations where you have acceleration or deceleration of the fetal heart rate based upon the contraction rate of the uterus during labor. And with that, you can also control the uterine activity, where it's a one-shot, contraction, or you can show the escalation of labor from 2 per minute, 3 per minute, up to 5 per minute. And the rest of it too, we went through it a lot in detail, but it does have a lot of capability. So if it's something you need to do it, that we probably have it in there someplace.
And it's just the basic
Just
stuff.
be a matter of finding it.
Yeah.
Respiration, basically that all of your thoracic impedance type measurements that are looking for the changes in the chest wall resistance, we're able to simulate that with this. Primarily, you're looking at something where you can set the baseline or the patient's chest resistance, typically 500 for the babies and 1,000
For adults.
for the adults. Some of the higher ones you're looking at for either very obese or geriatric with very dry skin on the electrodes. So this could be a good test also if you're looking at testing the ability of the monitor to work with different electrode conditions. And also, too, in many cases, if you go to 2,000 ohms for the baseline impedance, you're probably going to set off some alarms that says, hey, check your electrodes. There's a problem. It's a very high resistance. But values of 500 or 1,000 are very typical. And we also select the lead at which the ECG, the respiration comes out on the ECG leads. Most monitoring companies run lead 1, Apparently, I know that the Philips runs the lead 2 or RL to left leg. And especially when you're doing monitoring, right leg and left leg or the lower portions of the chest, and that's where you really do get the majority or the most of the impedance variation during respiration. Everything you need basically is there. If you're looking at just normal waveforms, we got the ventilator waveforms, full ranges of rates, and also the sizes of waveforms, the ratios, different apnea conditions. Also for your neonatal mode, it's called shift. And this would be a matter where, in a lot of cases, you have a baby who will, in an intensive care, critical situation where they'll inhale and then they'll start to pant, breathe very fast. Or they can exhale and breathe very fast. Well, we simulate that with this. It's a baseline shift where you do the increase and then you go to a fast rate, or you exhale and go to a fast rate. So you can see how well the monitor can respond to those changes in the signals. So especially for neonatal applications. Blood pressure, soup to nuts, both for static and dynamic. Temperature, we have 2 channels of temperature. This one is variable temperature, and that's all output right here. So you select either 400 or 700 series YSI probe, 3 fixed values, and then the other dynamic conditions. So you can check the temperature trend capability on the monitor, with this. It also included one fixed temperature at 37 degrees C, 98.6. So a lot of monitors have the ability to measure the differential between 2 temperature channels. So you can do that with this setup. You've got a normal of 37, and then you can go in and adjust this one. A lot of cases where if they're monitoring the site from a transplant or from maybe a reattached arm or something like that, they'll monitor, the main body and then the temperature of the peripheral, limb, and they can set it to where if the temperature differential between those two was high, said, hey, you got some problems here. Got that capability. Cardiac output, same type of thing here. For thermal dilution, we've got fixed values up to 7 liters per minute, and also we can run cardiac output trends. And there are also the artifacts, as you've seen before in other devices, for both ECG and also for blood pressure. ECG is just general testing for muscle and line frequency, that sort of thing. Blood pressure respiratory artifact is very helpful when you're doing the Swan-Ganz procedure, because that's where the artifact typically does occur when you're running that procedure. You're trying to measure very low levels of blood pressure in the presence of the patient breathing. So many of the monitors have these capabilities, especially the Hewlett-Packards, of zeroing out that artifact. So with it, when you're breathing, you can adjust, you can modify or create variations in your pulmonary artery and wedge pressures. So we simulate those conditions, but it's a pretty fine point. We have the ability for doing little sequences in here, and for example, it's a one. This could be something even good for training purposes. Right now it's a normal ECG. Starts putting out a couple of different PVCs, and then that activity will increase. So right now we could be doing this at the bedside in the patient's room, and if it was a larger hospital and they had a central station, we could walk over to the central station and see what they're going to do with it. It takes a little bit of time to go through it, but it gets there. So this is a good test for the alarm systems. There you go.
Yeah.
Right on the
That's
good ventricular tachycardia. This shit goes into grades to VFib.
ventricular. Oh,
There you go, VFib.
VFib.
And then goes down, degrades down to asystole. So by now somebody should have
This doesn't
thought about
recognize.
Now they do one more withdrawal from his Visa card and sends him out the back.
Yeah.
So there are a bunch of those in here, and that this allows you to do some things where you tie a lot of these different selections together. So there's a ventricular series which go through a wide range of ventricular arrhythmias, conduction defects or respiratory changes, and just a whole different series of things that you can do.
Bunch of features.
Yeah, it just ties, instead of just having to, okay, I want to do normal sinus for a while, now I want to do some PVCs, now I want to do some VTAC, and now I want to do some VFib, and I want to do some asystole. Just go to CCU, or cardiac failure trend, and it will automatically loop those together for you. So, and again, it's a very good test for looking at the critical alarms capability of any piece of equipment. And with that, the respiration channels, blood pressure channels, all of that works together. So as the electrical activity changes, blood pressure changes, respiration changes, and then when it goes down to this condition, asystole, as it's now calling it, which is correct, that it will then give you zero respiration, no blood pressures, and a flatline ECG. So again, a good test for the basic operation of the alarms.
So that means somebody's looking at the bright light at the end of the tunnel.
Yeah, there's a bright light, and it's the one that's down in the morgue in the ceiling.
I didn't understand this. I mean, the functionality for blood pressure. What kind of blood pressure?
These are all for invasive blood pressure.
Only invasive.
Right, we've done all of the non-invasive
Non-invasive.
blood pressure here. I wish we could make all that happen inside there, but it's just not enough room.
Okay.
And again, what this does, it simulates the, it's a strain gauge type transducer that would be measuring fluid or the blood within the patient's, within the heart itself or within its larger vessels. And with it, that we provide the cables for the different brands, and I need to I added the data scope. I'll add the Nihon Koden so we can also test those. Yeah.
So this is supposed to be used only for invasive
Exactly.
blood pressure.
So it would be for these
For the
or for these,
for these two.
and then you'll be able to run through and be able to do the full range of tests on them.
Okay.
So
Understand.
blood pressure. So blood pressure one is the most wide range, where you can have atmosphere or zero or a wide range of dynamics. Arterial being your standard 120/80, and that does walk through all of the values for the Swan-Ganz procedure. And then static calibrations too. As well, this generates static pressures pneumatically. This does it electrically. It simulates the response of the transducer. And with that, there's the switch position here. Best to keep it down here on 5 microvolts. Most of the transducers are 5 microvolts. Very few are the 40. Earlier Philips, which then were HP and Agilent, they had some of their transducers were 40 microvolts, but very, very few. All the ones that they do present now are 5 microvolts. Actually, some of the newer systems, they only are 5 microvolts. So that down there is always a safe selection.
Okay. Yeah.
Did all that, but I didn't plug it in.
All right.
Yeah, like I said before, we've again standardized with these types of battery eliminators, so that they will be good worldwide. It's 100
50,
volts.
60.
Yep, 50, 60, 100 to 240. And that they do have we did pay extra to get the Japanese certification, on those also. So like I said, it's pretty much everything. You've got the capabilities on that. It's just really more of a matter of figuring out what you want to do with the monitor and then saying, okay, well, now I'll just have to come back to my simulator and find the function or just look at the different menu for that. As you can see that we've done a lot of button pushing on this thing. We also have a new little handheld controller. It plugs into the RS-232 and it then controls the simulator via a keypad. So the basic functionality that you want to be able to go directly by pushing buttons, changing the heart rate and going to different arrhythmias. You can do all that with a direct keypad. But again, that's just another control tool. So you can do it manually, or I was thinking that we can come up with some other sequences. You can do that via the med tester. Let's hook this up to the med tester also and have it run it through its paces. It'd be nice just to see if we could just take one of these benches or both of the benches and set it up where the procedures and protocols, we have it all built into the med tester, and if you want to test something, you just type in a control code and then it goes out and controls the piece of equipment that you need to get the work done. So I'd like to work with you to make that happen.
High productivity.
Okay, other basic things that are on here, it's if you have ECG leads, the disposable ones you can plug into here.
And test them.
Yeah, you can just test them. If it's a short, the light illuminates. And if it's a good 9-volt battery, you can also test them across those terminals too. So just a real quick way of doing the test. You may in some cases need to use the high-level ECG. This is a 1-volt level signal, whereas these are like all 1 millivolt levels. But if it's an older central station, it may have requirements for a higher level ECG. So we just simply have that capability.
Yeah.
Okay, as far as maintenance on this, if you're going to be using it on the bench, I would recommend leaving it plugged in, like I didn't do, because if you're going to run around with it on battery power, you're going to need to replace the batteries from underneath, and that is just we've got a small compartment right here, and
9 volts.
Yeah, so we can actually, the adhesive is better than we thought. Yeah. And this is just the location for the EPROMs.
EPROMs.
So you got the full load. You got the
Yeah.
full cardiac output. You got the option 1, so you're ready to go. So I think you're going to get a lot of good service out of this. It's a good rugged unit with a wide range of features.
That's fine.
Great. Any questions or any ECG simulation mode or some other simulation parameters? I think we got it pretty well covered here. But I beat you to death with it. With our equipment, we do cover the full range from ECG, respiration, blood pressure, temperature, cardiac output, non-invasive blood pressure, and then pulse oximetry with the index. Right now we don't do anything for end-tidal CO2, which is the concentration of the CO2 in your exhaled breath. We don't do anything in that area right now. But all the companies that sell that equipment, they basically just use a static calibration for gas samples. And that seems to be adequate for that purpose. So most of the things we've got pretty well covered. And some of the other simulation devices, MPS 450 is somewhat comparable to medsim feature-wise. This just does have a little wider range of simulation feature. But the other ones, like the PS 420, which one's from the Metron side, a little bit different, but it's a little bit smaller, so maybe we can look at those for the kits and things possibly. So it depends on what we end up working with you on for the the field kits. But pretty much anything you need from basic ECG to the full monitoring testing capabilities, we've got you covered.
So you have a fetal monitor, so you may want consider to have a PS320, which can generate fetal ECG.
You said something.
Yeah, I think looking at there's a fetal heart rate detection series for the biomed training program. So we do have a external mechanical fetal heart that works with that simulator. So it will be something where you could check the ultrasound, cardiac probes for that. And again, too, this can be used for testing the different fetal monitors from the direct mode after the mother's water is busted and they have access to the crowning fetal head. You can simulate the fetal ECG off of this, and also the intrauterine pressure can be simulated with the 4th BP channel.
BP channels.
So, and again, that's in the manual. All of those special option functions are rather well described in the manual graphically too. Okay, well, I about talked myself out on this sucker, but if you have any questions or like as you use it, if you have any other questions, let us know, because what I do want to do is just make a little inventory around and make sure that we've got all the cables that you do need to run this. So we can kind of take that up and walk around and get some blood moving through me. Great, thank you.
Thank you.